using their transformations, okay? We're going to make an XY chart, but we're also going to graph it using their transformations. What I mean by transformations. Okay, this right there, okay, absolute value of x. If you were to graph this, what you're looking at is it's yeah, that's a definite x. I just have to figure out what it is. All right, if it's 1, the absolute value is 1. If it's 2, the absolute value is 2. If it's 3, the absolute value is 3. Right? Well, 0, 0. If it's negative 1, what's the absolute value? 1. If it's negative 2, what's the absolute value? 2. If it's negative 3, the absolute value is 3. So an absolute value function looks something like that. It's a V shape. Okay? It's a V-shaped graph, like value V. Okay? And what we're going to do is we're going to look at the transformations. This is called the parent function. And we're going to transform the parent function. Inside the absolute value bars, anything inside the absolute value bars is going to move the parent function left to right. It's actually going to do it opposite what you would think. Okay?
So name would be function.
Right. What are the chances that I can change color? Anybody think that that's going to happen? I can. I mean, it's possible, right? I just don't know that I can.
What if we had 10 probably?
Oh, I need to go here and do this. 10. Yes. Go home, okay? Yeah. All right. So if I put, if I put 1 in this time, it's not going to be just the absolute value of 1. It's the absolute value of 1 minus 1, which is 0, right? If I put 2 in this time, it's not just 2, it's the absolute value of 2 minus 1, which is 1. And this is going to be here. 3 is then going to be 2. Well, what's 0 going to be?
Negative 1.
Which the absolute value is 1. So when you put something inside the absolute value bars, it moves the parent function left to right. Okay? It slides it over. And it moves it almost like what we need to think of opposite. Minus is going to change, it's going to move it to the right. Plus is going to move it to the left. Okay? Let's change it a little way, because I don't want to see that. Yellow. I think you can see that then. Can you see that?
Right. I mean, I can see it.
Yeah.
Plus
Wow.
Is that plus 1? That's going to move it up or down.
Right. Outside's going to move it up or down. Because here's basically what's happening. I can't read that. I don't know about y'all. I got to change that. That's not what's happening. But here's what's happening. Inside the grouping symbols, which we're going to call absolute value bars grouping symbols because it counts for any grouping. Inside, you're dealing with the input, which is your x value. So that's when it changes the x, because you're dealing with input. Once you get outside, which is this one right here, you're dealing with, oh look, that's the spirit, not you. Once you get outside, you're dealing with the output, which is your y value, and that's what moves it up and down. Okay? And that's also true for quadratics, circles, ellipses, hyperbolas, all that fun stuff. So let's look at this one. If I take the parent function, which is the red one, if I just need the absolute value of 0, that's 0. But then I add 1 to it, so it's going to be right here. If I take the absolute value of 1, that's 1, and I add 1 to it, then it's not going to be here, it's going to be up here at 2. 3 is now going to be, or 2 is now going to be at 3. 3 is now going to be at 4. Negative 1 is now moved to 2. Negative 2 is moved to 3. So it takes our absolute value, our parent function, and moves it up 1. That's what the outside does. The outside moves it up and down. Inside moves it side to side. We're going to practice doing some of these. Dalton was nice enough to walk down to the office and get copies for us. So I've got some graphs that you can use. Yeah. You don't have to. I mean, you can use notebook paper if you want. I just think it's probably easier on the graphs.
No.
Yeah, well, I tried to figure out what's going to happen with this 1/2 on the outside. What do you think's going to happen with that? Ideas? I got an idea. You got an idea?
I thought I had one, but I don't even know if I got it wrong.
Okay, what's your idea?
Like it looked like a slug, like one of them.
That's sort of what's going to happen. It's going to, it's outside, okay, so it's dealing with the output. It's going to increase half the amount, basically. So if our parent function is this, oh no, not in here. What the heck? Anyone who watches is going to be like, this teacher is insane. How do these kids learn anything? Alright, so that's our parent. So thinking about parent function, 1 is 1, 2 is 2, and all that, okay? So this time, if x is 1, absolute value of that is 1, but half of that is, yeah, 0.5. I'll never get that graph. 2 would actually be at 1. 0 is going to be at 0, right? How about negative 1? So 0.5. Remember, we take the absolute value, and then we multiply it, so it's going to be 0.5. And negative 2 is going to be 1. Okay, let's see what my chances are of changing the color. Alright. So 0 is still at 0. 2 is now at 1. So it's just going to make it open wider, that 1/2. What do you think would happen if it had like 3x instead of 1/2x? Right, it would go.
So instead of 0.5 would be 3,
Right, so it'd be skinnier, right? Exactly. Okay, so 2 should be easy, because 2 is just going to take our parent function. And what's it going to do to that parent function? What's it going to look like? It's inside, and it's positive. 2 to the left. Right, so this whole thing is just going to go right over here. That's my new one. Exactly. The green is the norm. What about a negative outside? What is that going to do? I'm going to move it down. Well, sort of. It's going to take it from here to here. do this in like 3 steps, okay? So the parent function looks like this. Oh my goodness. Pretend it looks like that. I'm bad. That's the parent function. And then minus 4, what does minus 4 do on the outside? It just slides it down, right? So here's minus 4 on the outside. And then what does the negative do? Flips it. So it would be this right there. The black one is the final product. Alright, great. Okay, so okay, that's fine. See what you do now? Look at that. Okay, try 4, 5, and 6 on your own. Do 4, 5, and 6 by yourself. Alright, so absolute value x minus 4, and then I'm adding 5. So what's going to happen to this one? It's going to move right. And it's going to move up. So the vertex is going to be here. And we're just going to go from there. That's what
On our test, like if we did them, like I put the step by step.
like you started with the parent function?
I did it with 4. Now 1.5.
Yeah, that's excellent if you did it like that. That's fantastic. I have no complaints. Alright, what about this one? It's got that 2 right there. Right? So it's going to move down 4. It's going to, see, I can't line this up because the numbers are on. It's going to be skinnier, right? Like that. Okay. A negative 1/3 minus 1. It's going to be fatter, right? So if my parent function is here, the minus 1 on the inside is going to move it here. Now what's that negative 1/3 going to do? It's going to flip it and make it wider. It's going to flip it and make it wider. Yeah. So this is still going to be here. But then instead of 1, 3.3. Right. So it's going to be all the way over to here. Oh, I didn't even need to do that. Awesome. Easy stuff, right?